protože nám touto přednáškou, minimálně přednášková část COFITu končí. Je to na mé oblíbené, já jsem normálně, opravdu jsem takový magor, že jsem nemohla dospat, tak jsem se na to těšila. Je to strojové učení a umělá inteligence. Už loni tady ta přednáška byla skvělá, oni jsou samozřejmě všichni skvělí, ale tady to je opravdu blízko mému srdci, takže se připravte na takovou lehkou hodinku a 3/4, 2 hodinky, máme to opravdu nabušené. Já jenom ještě, než se do toho pustíme a přepnu do angličtiny, protože většina speakerů má své prezentace v angličtině, snažíme se jet hardkorovým bilinguálním způsobem, tak bych ráda zrekapitulovala konec minulé přednášky. My jsme dnes měli už v 10 hodin ráno manažerskou informatiku, kde jsme vlastně řešili vůbec jakoby ten překlad mezi tím, super, tak máte technologické řešení, ale jak je to v hospodě na mítince, ale chodili mu tam lidi, musíte vždycky jako jednat s lidmi, musíte je zmanagovat, musíte zmanagovat Scrum, Sprint, musíte pochopit různé procesy, takže tam jsme právě řešili to překlenutí mezi strojem a člověkem, jak je to důležité se k tomu lidsky a pragmaticky postavit. Potom v 1 hodinu jsme měli webové aplikace a rozsáhlé softwarové systémy a vlastně tu tvrdou realitu implementace technologických řešení i třeba ve velkých korporátech. A právě tak jako hezky tematicky k tomuto tématu nám ke konci toho streamu schořela elektrika, takže pokud vám ten stream vypnul a neslyšeli jste už konec Jaromíra Mlejnka z České spořitelny a toho, co se skrývá za Georgem, tak tam nasdílel jakýsi QR kód, který si můžete načíst a potom se třeba stát součástí vývoje George aplikace. Určitě běžte do stánku na Togetheru, nejenom České spořitelny samozřejmě, ale i našich ostatních partnerů. Pokecejte si s nimi, zjistěte, zač toho loket vůbec v spolupráci s průmyslem, protože čím dřív si to oťukáte, tím líp pro vás jako studenti. Samozřejmě potom jsem se ještě ptala na jednu poslední otázku a to mě vlastně jenom zajímalo, jak dlouho to trvalo, než George přešel z koncepce do realizace, tak prý se vykoplo s nápadem v roce 2015 a potom už vlastně za pár krátkých let byl na trhu, takže ono to trvá, než se tady ty věci dají do pohybu, ale potom je krásné sledovat, jak optimalizují takové ty tradiční instituce a procesy s nimi spojené. Tak to jsem vám jenom chtěla zrekapitulovat ten konec, který jste bohužel neviděli, ale přišli jste jenom po 2 minutky asi, tak nebojte. Všechno samozřejmě bude zpětně ke shlédnutí na YouTube. Ale teď už se pustíme do strojové učení a umělá inteligence. Máme před sebou laboratoř datových věd, takže jako vždy to vykopne naše skvělá laborka, v tomto případě Data Lab, potom už Cisco, Profinit, Deloitte, PwC, Datamo, H2O a Recombí, takže máme toho opravdu hodně před sebou. Já jsem si vědomá toho, že to uvádím trošku jako chcete být milionářem nebo riskuj, takže se omlouvám za přehršlý entuziasmu, ale bude to opravdu moc prýma. Co se týče jenom rychlé představení laboratoře, tak určitě já to udělám jenom po povrchu, protože tady daný představitel to udělá určitě mnohem lépe, ale věnuje se to právě sběru různých dat, různých druhů dat a jejich zpracovávání, ale samozřejmě i přespracování, protože, jak víme, tak umělá inteligence není magie a když do ní dáte blbá data, tak vám vyleze blbý výsledek, takže laboratoř se hodně zabývá touto datovou problematikou, ale i právě algoritmy třeba data miningu a potom i různé aplikace strojového učení, například segmentace, klasifikace, predikce, doporučování a detekce anomálií. Detekce anomálií je mi velmi blízká. Pamatuju si, když jsme řešili v rámci průmyslu 4.0, jak predikovat poruchy strojů pomocí zvuku. Byla to velká legrace, ne vždycky to fungovalo, ale naučilo mě to hodně o AI a já se těším, že se toho ještě více naučím během dneška, takže já už se přestanu vypovídávat a Petře, je to vaše. Moc se těším, díky. Actually, sorry, switching to English, welcoming Petr from the Data Lab to tell us about the basics of their research, machine learning, segmentation, data processing and pre-processing, and all that jazz in between. Thank you very much.
Hi, everyone. Hello, can you hear me? Yeah, I hope so.
Yes.
Hopefully you can see my screen.
We can see it, but we can see the browser.
Okay. So,
thank you.
Sorry. Oh, sorry, I tested it a few minutes ago. No, I can't. For some reason, I can't change the...
Don't worry, it's always like this.
Yeah, I have troubles to quit the screen sharing because I apparently shared the wrong screen.
Would you like to restart? And I can say some funny tales from the world of artificial intelligence in the meantime.
Please, thank you.
Okay, no problem. Or actually, yeah, what we can do is rather than me just talk endlessly, which is always dangerous, we can invite Cisco to go first, and then Petr, we can have you straight on, if that's all right.
Yeah, please.
Yeah, cool. All right. Well, in a untraditional, dramatic turn of events, let's first turn to Cisco, and then we will have Data Lab. So, Cisco, if you could please kick off. You have been cast into the jaws of darkness. We look forward to hearing from you, and specifically your talk, Machine Learning with Highly Imbalanced Data. Thank you.
Okay, so hello everyone. Let me share my screen. So looks like I cannot share right now because...
yeah. Hopefully it's okay.
Yeah, it should be. It should be. So just a moment. Okay, so is everything all right?
Perfect. Thank you very much.
Okay, so hello everyone. So my name is Jan Brabec. I am a technical leader at Cisco Cognitive Intelligence. And this will be like short introduction into how to evaluate classifiers with highly imbalanced data. What does it actually mean? And also in the end, I will kind of show you the opportunities we have in Cisco for student collaboration. So let me start like very broadly. So just like to remind everyone, like this is the basic framework like we use to train like classifiers in machine learning. So we have some data, we split the data into training data set and where we actually train some model from the data. Then we actually need some other data that the model has not seen in training, and we evaluate the model on this data and measure the performance of the model, which very often is accuracy of the model, meaning how many of the data points were classified correctly. And so let's take a look at some like common data sets that are used in machine learning research. And one of them is MNIST, for example, is very well-known data set of handwritten digit classification. So the state-of-the-art accuracy on this data set is 99.84% correctness, basically. Which is like almost, I think it's maybe like equivalent to human level, maybe even better now. The other very well-known data set used that was very impactful, that actually caused this huge deep learning boom, is ImageNet, which is basically a data set of 1,000 different classes of images. And again, the state-of-the-art accuracy here in like top 5 classification is 98.8%, which is like amazingly high, considering that you need to select from 1,000 classes. And this is a very impactful data set. Is actually it's actually underlying lots of actually production models in computer vision deployed. Like lots of things are actually still trained on this data set at their core. And to not talk only about images, for example, in natural language processing, when we want to do like sentiment analysis, which is basically the task of predicting whether text has like positive or negative attitude. We use data sets like IMDb movie reviews, where the state of the art is around 97.4 accuracy. So you can see like the pattern, like when you have these data sets, like the accuracy is very, very high. So this looks great. What do these data sets have in common? Many things actually, but the answer for this talk is that in all of these data set, classes are perfectly balanced. That means that all of the classes have like the same amount of examples, both in the training and in the evaluation scenario. And this is actually not like a scenario that is in real life encountered very often. Many real life problems are actually like searching for needles in haystacks, not like classifying between two likely scenarios. And examples of this are in many industries. So of course in healthcare, when you want to classify disease from whatever data you have, usually the diseases are quite rare compared to normal conditions. In cybersecurity, which is our field in Cisco, we are looking for like advanced threats and even like malware attacks. And again, there are huge imbalance ratios here. Like we are talking about 1 in 1 million, and even less is like the number of like dangerous communication or dangerous binaries or really dangerous emails, even though in email it's a bit higher compared to like the benign cases. In industry, we have many cases for machine learning where you can use it. So for example, when you do like quality control, looking for defects, hopefully the defects are quite rare. So again, you are faced with inbound scenario. And now what's the problem here? So imagine that when you have a class imbalance of 1 to 1000, basically, so 1 in 1000 is the class of interest, the positive class. For example, the malware binary file. Then basically like always predicting a majority class, like in the case like the benign, gives your classifier like 99.9% accuracy. So you get basically high accuracy that might look good on marketing material, but really your classifier doesn't do anything interesting in the end. So what to do with this situation? And we might ask, are there better metrics than like accuracy for this scenario? And the answer is yes, of course, there are. And so in the rest of this talk, I would just like to quickly show you where they come from. So back to the probability and statistics course that I think some of you had and some of you are still having, maybe even in this semester, I'm not sure. So let's remember this task that you will or you have encountered, that like a doctor can administer a medical test that comes out positive for 95% of patients with disease, but also comes out positive in 5% of patients without disease. So, and the disease prevalence in the doctor's district is 3%. And the question is, what's the probability that the patient is affected by the disease if the test comes out positive? So this test is in fact a classifier, so it can be a machine learning classifier. And so let's draw the situation. So this is like a set diagram, so the blue rectangular set of all patients in doctor's district. We can divide this set into like healthy patients and patients with disease. So this is the ground truth that we do not actually know, but we know that it's around 3% proportion of the patients with disease. And this is like the patients that have positive tests. So you see like there are some false positives, there are also some false negatives, but of course like the classifier kind of works most of the time correctly. And so the probability that if the patient has disease and tests positive is like 95%, that was set. The probability that the patient is negative and tests positive is like 5%, that was also set. And the question is, what's the probability that if the test comes out positive, then the patient has disease? And the solution to this is like maybe using the most important theorem in mathematics. There are some competitors, but this is really a really important theorem, which is the Bayes theorem. And when you apply Bayes theorem, you basically come out with a number of 37%, which is surprising Usually it's a surprising result to see people that see it at the first point, because these probabilities seemed quite high, right? The test is like 95%, kind of has true positive rate 95%. And in the end, the probability that you are really positive if the test comes out positive is only 37%. And this is what's underlying issue anything when you deal with imbalanced data set. And actually, these are the metrics that we use when we work with imbalanced data sets. We just call them a bit differently. So the first probability we call true positive rate, the second we call false positive rate, and the one that we were interested in computing we call precision, and which also can be called like positive predictive value. The other have also several names in different fields, but they are basically this probability, which is interesting to measure. And so, what are the takeaways from this very short talk? So, many real problems are class imbalance, often very heavily. So, in our case, in cybersecurity, it's like 1 in 100,000, 1 in million. For these problems, accuracy is not a good measure for performance of classifiers. And also takeaway that I didn't mention, but I want to mention, is that imbalance really brings interesting challenges into classifier training and evaluation. So I talked about the evaluation, but of course, there are many opportunities how to take the imbalance into account during training, and still many open questions, even though the problem is kind of studied for quite a long time. And last, something about what we can offer at Cisco. So we are looking for students for collaboration for bachelor and diploma thesis. In the past, what's the advantage is that we have defended tens of successful theses in the past. So I don't have the exact number, but it can be around 50 or something like that. So really, we have the experience in leading student projects, and of course also even winning some prizes with some of the theses. Here you can see the topics we can offer. So we are now interested in applying self-supervised learning to cybersecurity, classification with imbalance with imbalanced classes, learning and inference of graph structures, mostly applying graph neural networks, which is a very hot topic also in machine learning research. We are working with not only with network data, but also with email data. So we try to detect phishing from email content. We want to classify devices in network, and also we have some interesting topics in some paradigms like multiple instance learning in cybersecurity, and probably some more. So these are just high level topics, and not the low level topics that we will come into agreement after we kind of sit and discuss what to work on. And if you are interested, here is my email. So please contact me here. And now I'm open to the discussion.
Thank you very much, and thank you for the pragmatic view of what it actually does to the outcome of various algorithms when there are imbalanced classes, and when there is things like data bias, or when you train it on very specific data sets that give you a very specific beautifully looking results of amazing accuracy, but then all it takes is to swap the data set or change one small variable and the result is completely different. On that front, I'm wondering whether you could please maybe, again, maybe not so much for the students, but demystify for the public that might be watching this. There has been a lot of hype because AI is such a buzzword and machine learning is such a buzzword that when you type AI into Google, for example, the news and the articles that you get mainly have very negative connotations, often related to racism, sexism, racist algorithms, sexist algorithms, but all of these derive from what is fundamentally imbalanced classes and biased data. However, what that then leads to, and I saw that in my career in startups, is that you go to the decision makers in the companies and they say, oh, but we don't really trust AI. And they almost give artificial intelligence these humanoid features. They don't realize that their data's shit, to be quite honest. And they give AI these humanoid features, and it takes half of the sales cycle only to explain what AI is and isn't before you can even proceed to the nitty gritty. So maybe your perspective on this media hype and negative wave that has been happening in recent months and years. If you could help us demystify that a little bit, that'd be great.
Yeah, so that's of course like very, very broad question. So of course, like many things are like wrong, and some very often are like incomplete products like shipped into like places where they do not belong and where they can affect like negatively the outcomes, and sometimes can have like very, very severe negative effect on real people. On the other hand, of course, like as with every technology and as with everything new, there will always be like kind of people that go against the technology. And yeah, so I think it's kind of hype from the both sides. So in the end, when we work on the topic, lots of the things that look very scary or very exciting from the outside kind of become a bit boring, but that doesn't mean that these things are not exciting actually. It's just that they are a bit more difficult than, and sometimes much more difficult than what might seem to appear on like when you have shallow knowledge of it.
Thank you very much. No, it's good to be skeptical to both extreme sides of the spectrum. But I think that your presentation, and especially with the implications of imbalanced classes for things like network security and very concrete examples, I think helped demystify that in its own sense. So thank you very much, Jan Brabec for Cisco, and thank you also for saving the day with jumping in first. I would now like to go to Petr Šimánek from the Laboratory of Data Sciences, or Data Lab from FIT. Are we ready?
Hi again. Hopefully this time it will be better from my side.
Awesome. We can see everything. We can hear you.
Perfect.
Take it away.
I believe that AI would do a better job than me connecting to this. Thank you, Sarah, for your introduction. I will introduce myself or our group a bit more. We are a laboratory of data science. We are in the big building A in 13th floor. What we do most of the time is applied and basic research in AI or in machine learning and data mining, altogether AI. We work mainly with industrial partners, but we also supervise bachelor diploma thesis, and we can run projects with students. I will show you some of our results. Those of you who were here last year maybe saw some of these, but we have new results. Don't worry. We have very strong, interesting, and fruitful cooperation with company Meteopress. We are working on multiple ways how to revolutionize better prediction by AI. And we seem to have quite a good results. Like here we are trying to predict rain, like predict radar images in next 1 hour to show you if there will be some hailstorm or something like this, if you are able to leave your house for a moment. We use quite huge, complicated recurrent neural networks, which are even fused with some physical models. The results are really good. I believe they are much better than most of the competitors or most of the other solutions that we can see right now. We are also working on like longer time forecast. It's for up to 2 days, and we are not predicting only rain above Czech Republic, but we are predicting the weather worldwide. We are trying to use some advanced neural networks for post-processing of numerical weather predictions. So all the huge supercomputers that work for many hours to create some predictions. We used their results and do post-processing with AI, with neural networks. And it turns out that we have state-of-the-art results, which is really interesting way how to improve this and make it cheaper as well, these predictions. One thing that we are very interested in, and we see that we found improvement, is prediction of extreme weather, which turns out to be more and more important with the current global change or global warming. So this is something that we are very interested in. We are starting a bigger project in next month. So possibly if some of you are interested in cooperation, please contact us. Our very strong and important partner is Škoda Auto. We cooperate on many projects. I will mention only one of them. It's connected to car aerodynamics, where car aerodynamics is very important for, let's say, lowering CO2 emissions, for increasing driving range of electric vehicles, and so on, better driving. Right now, Škoda runs a lot of very expensive physical simulations and also measurements, but these are not enough to understand the aerodynamics. It's quite difficult even with these simulations to understand it. What we did is that we used AI to explore causal relations in aerodynamics to help the engineers to understand what's going on, what to change to improve the aerodynamics. Together with Škoda, we were able to buy these cars, robotic cars, Deep Racer and Jet Racer. With these cars, we would like to do a lot of experiments with autonomous driving, like detection of road signs, some maneuvers, or distributed coordination of multiple cars, let's say, to avoid collisions, and also races. And these cars will be available for students, for projects, bachelor thesis, diploma thesis. So if you are interested, don't hesitate to contact us. We are also working with Saint-Gobain, so it's a completely different application area. Also, what we are doing here is similar to anomaly detection, as Sarah mentioned, but this time we are trying to understand what's happening inside furnace, which is producing insulation mineral wool, and we are trying to understand it, control it, to reduce CO2 emissions and also coal consumption. So this is also pretty cool. We have very interesting results, which are about to be applied in next month, I hope. And now, different or completely different topic, which is a bit more ambitious, is that we are working with Good AI on this very ambitious project of artificial general intelligence. Good AI is trying to approach AGI, artificial general intelligence, with multi-agent meta-learning. We are working with them, developing some learning to optimize methods. And there are many open topics in basic, but hopefully applicable research. We work there with many world-class experts, which are very good in their fields or outstanding in their fields. Also, if you would like to cooperate with us, please contact us, and the contact emails are here, or once you would be allowed in university, you can knock on our doors. So thank you very much for your time.
Thank you very much, Petr. I would like to encourage the students to ask questions if you have them. I have plenty, so it's fine. I can fill the time, but I would love to give you the opportunity to ask. So please don't be shy. Go to the atrium and ask away. I have two questions, please. One of them is on the Saint-Gobain furnace. I remember that we were doing something similar when we were trying to listen to basically like the activity inside the furnace and then analyze the sound that is happening inside and search for anomalies or like anomalous patterns. But we had a problem that our piezo sensors kept melting, and that basically there was no microphone or any sensor that could easily, that didn't cost like thousands of euros, that could collect the data that we could then build on. So in this particular case, and in other cases as well, how difficult is it to sometimes actually get your hands on the data set so that you can analyze them?
Actually, in this project, it's rather easy. They have very good data, very well prepared, very well curated. So this is much easier. But the problem is that you need to predict what will happen in 1 hour with data which are like in very good quality, but it's very difficult because all the environment, like all the data are chaotic, so very difficult to predict, and we need to understand at least somehow what's happening inside. So we are learning a lot of their domain knowledge to learn what happens if the temperature is over 200 degrees and lower than some 300 and so on. So it's quite difficult.
Well, your wonderful answer actually is a great segue into my second question. Because machine learning or artificial intelligence right now is often very, very task specific. So the domain knowledge is very important. Very specific data collection and labeling is very important. At the end, you mentioned the work with good AI and artificial general intelligence research, which I also know that Tomáš Mikolov is engaged in. It's really interesting that like generality of AI being able to solve, I'm not saying like any problem, but like a wide variety of problems without being instructed on how to do it. Like what is your opinion in terms of, I know it's difficult to predict, but like when we're going to have the next breakthrough, or like how close or how far we are, and like how is your laboratory engaged in this? So say in 5 years time, where would you like to be in this regard? What would like success look like to you? I know it's like the $1 million question, because like if we knew, then we would have it already. So I understand that it's a bit of a chicken and egg, but I'm just really curious about your opinion.
I think from what I saw, we are definitely getting closer and closer. There are really, really strong steps done in this area. I really can't say, but once we make this breakthrough, then it will be very, very fast. So yeah, I think the topic is to make something which can improve itself, and it can improve the way it improves itself. so it's a bit difficult, but once we reach this, it will be very quick, very, very easy.
Thank you. And maybe one last question. We're with organizations like Prague AI, but also with FIT, ČVUT, and like this ecosystem that we have here. We want to show the world that Czechs are good at machine learning and good at AI. Do you have a message maybe for the students who, I know that we face a big brain drain, but I also feel that that is reversing a little bit, and that people are starting to come back and appreciate the value of the local ecosystem, and that we have really good technological education. Do you maybe have a message for them that like why we're good or what we're really good at in terms of AI and machine learning, just to give the students a bit of a healthy boost?
I think we are very good. We are very good at it, and it makes sense to stay here in Czech Republic because you can be part of something quite big, or starting to be quite big, because more and more companies are trying to invest inside in AI, and also we have good theoretical background in many universities around the world. You learn how to use it, but it's you don't have good enough background in mathematics and statistics, and so which in ČVUT or other universities in Prague you definitely have. So I believe it's really really good to stay here in Prague, and yeah, if you cooperate with us, you can be sure that our students can be sure that they will work on very state-of-the-art projects.
Thank you. Thank you very much. Students, you heard that. If you want to investigate furnaces, the weather, and artificial general intelligence and the meaning of life, and basically be like a Greek demigod, then you got to join FIT ČVUT and join the local AI research team, specifically Data Lab. Petr, in all seriousness, thank you, and thank you for giving us this presentation. I'd love to now bring it on to the next speaker, who is Dominik Matula from COFIT, who'll be talking about data mining of financial transactions. In the era of cryptocurrencies and blockchain and the financial market being very, very turbulent, I think AI has a lot to say in this regard, as well as the way that we approach data in the financial transaction area. And I look forward to Dominik's presentation. So Dominik, take it away, please.
Thank you, Sarah. Hello again. I'm glad you are here to see my presentation. In the following 10 slides, I'd like to present you some interesting data science and big data projects we are working on in our company, Profinit. So hopefully the presentation is over there. Great. My name is Dominik Matula, and I'm senior data scientist at Profinit. I'm focused on data science applications primarily in finance and banking sector. I'm a member of 2 research groups. In the first one, we are building social networks based on banking transactions. And I'll touch this topic briefly in following slides. In the second research group, and I'm a team leader over there, we are utilizing modern machine learning techniques to detect fraudulent behavior. On this ongoing research, we are collaborating with guys from your faculty, FIT ČVUT. And one of them is Petr Šimánek, you have already heard. So hi, Peter. Okay, let's move on. You have probably heard about our company, Profinit. We are one of the top Czech software houses, and we are also a gold partner of your faculty. Of course, we do all this stuff mentioned over there. We do software development, data warehousing, application outsourcing, and so on. But today, I'm here to tell you something about our youngest competency, big data and data science. We have started doing big data stuff back in 2015, and nowadays there are more than 60 people working on various projects. So let's take a look on some interesting ones. And as I already told you, we'll start with this paradigm. I forgot this slide. This is how we see and how we build our data science competency. We base it on collaboration with top Czech universities. We do some research with them, and the know-how gained from this applied research we utilize on projects and solutions we are offering to our customers. That's because, there are a lot of smart people already there, and to bring them some added value, you need to stay on the edge. We are also teaching several subjects on these universities, and we are a student-friendly company. We offer part-time jobs, diploma theses, etc. And now let's take a look on those interesting projects. This project is the so-called pseudo-social networks, as I've already mentioned. Do you know what those giant companies in the bottom have in common? They have effectively mined a data sentence, customer loves something. video of kittens on YouTube, Mandalorian TV show, a Facebook group of coffee lovers, etc. And based on this knowledge, they can predict clients' behavior and offer him more relevant content. And now imagine the possibilities the bank could have if the bank has this data. Well, let's think about the person in the middle. This client, let's say that he added himself to the 2021 Olympic Games in Tokyo, for example. Well, now bank can offer him insurance and money exchange and help him do some search on accommodation, etc. If you know your clients by heart, you can offer them more relevant content, and the more relevant the content is, the more loyal your customers are. It's pretty much the same as for the Netflix, for example. Unfortunately, your bank typically doesn't have this data. And here comes our project. During our research, we have developed an algorithm. How can you build such a social network based on financial transactions? Very simply said, you can just replace time spent and likes and other stuff you know from real social networks by money, by real money, either payments, withdrawals, etc. And voila, there is a social network built. And based on this network, you can say a lot about your clients. What are we able to say based on this network? Well, we can describe clients' behavior based on his social bubble. We can do some segmentation of a client. We can tell about her hobbies, about her or his family, etc. And that's very interesting and very important if you are doing some predictive modeling. You know, nobody is living alone in the universe. And if you know client's social bubble, you can more precisely predict his behavior. And there are two other stuff over there. We can do some pattern matching based on this social network. And it's useful for anti-money laundering activities in a bank. And last but not least, we are using advanced techniques based on, for example, neural networks. It's called graph embeddings to reveal hidden structure, hidden links between clients to get even more precise neural network. Okay, so let's move on. Unfortunately, I have only short time slots, so I can't introduce you all our interesting projects. But to let you know the breadth of our competency, I've put here some topics we are working on, or we are solving on our projects. As you can see, there is some client segmentation, risk scoring, and behavior analysis. There are things related to security, fraud detection, malware detection, online identity. There are stuff related to I don't know, predictive maintenance, image processing, etc. And of course, it's not only about the stuff from machine learning. You need to follow modern trends even on the technological stage. This is a must. If you want to deliver useful solutions to your customer, you need to speak their language. And of course, you need to be able to give them helping hand if they are stuck. So we are following these modern trends, and also we are teaching this stuff either on universities, in external or in internal workshops. And this is the very last slide from me. if you are interested in our projects, if you want to ask some questions, don't hesitate to contact me or my colleagues. After this session, I will be in Together platform. Also, I'd like to mention the Open Data Lab. This is a common platform founded by our company, Profinit, and your faculty, where you can find various projects and topics for diploma thesis, etc. For example, like a week or 2 weeks ago, 2 of my colleagues from Open Data Lab, they were in newspapers because they come up with some project based on vaccination, etc. So if you are interested in data science and open data, you can stay in touch in this platform. So thank you for your attention. And Sarah, it's yours.
Thank you, Dominik. Thank you very much. We have a question that popped up, but it's actually very similar to the question I wanted to ask. I might just give it a little bit more context. There's several things that popped up. The idea of the network being open, and it also, we discussed it previously in the software talk, but the idea of open source things where that can gather data easily, that can basically be much more open to the digital hive mind, that are not so closed up, and also have the implications that they're often for free and that they're not licensed. But the idea, you also spoke about how to actually construct the social network, and it really resonates with me because there's a lot of themes right now being discussed in terms of the social implications of the wider implications of artificial intelligence being scaled in society. So decentralization, the effect on the way that people like group each other, the way that society is going to be organized, the way that data flows, data is collected, etc. But that also has implications for data security. And there's been a huge kind of discussion that is becoming actually kind of schizophrenic, that on one hand, the data and the digitalization gives us immense freedom, and things like blockchain and being able to be in charge of your own data and being accountable and having it in one place online is really liberating. On the other hand, people are very worried about its abuse because they have extreme cases like China and it's spying on people. Although I think that often China and the US don't need to say anything to each other because they can sometimes be as bad as each other with spying on their citizens. But the whole idea of data security, but also data ownership, and then having that data so that we can develop AI in the first place, is becoming a very complicated discourse. What is your opinion on that? And where does the private sector play a role in that?
Well, it's a complicated question.
Huge question. I know. I have no mercy. It's a question for
a whole night in that, probably.
I
know. That's the fact. That's not something you can choose if you want to participate on this thing and move it a little bit forward. That's just a fact we are facing. So it's very important, in my opinion, to study these things, to be able to follow the trends and to use them wisely. Well, as you already said, there is China and others who are developing modern algorithms, modern techniques. How can they use machine learning in a public sphere? For example, like Big Brother, based in China, and you know, if you don't know these technologies, if you can't face them in your environment, they will overcome you.
Absolutely. And I have one more quick follow-up question on that. People are often scared of data being abused in the hands of the state, but in terms of companies and big institutions that are private but have some functions of the state, like Twitter or Facebook or big banks, people are starting to be skeptical towards these institutions holding their data as well. Can you maybe, again, demystify it a little bit for the public or the students that might be watching and may have ethical concerns, what you're doing to prevent that data is stolen, leaked, anyhow abused? I know that it's like an everyday reality for you and that of course you secure them, but there's a lot of misinformation out there about how this actually works. So if you could tell us a little bit more, that would be great.
Mm-hmm. Well, as I already told you, we are consultancy. We don't own any data. We are working on data. The banks and others they already have, and we don't have any our private data. So we have to follow their security guidelines. And typically in our research, especially in our research, when we are collaborating with your faculty and other university, these kind of data are anonymized or pseudonymized. Yeah, so we can't see much information from the data in the straight way. You don't have a table where it's written your name and your amount on your banking account, etc. There is just some hashes, etc. And therefore, we developed this technique based on social network because it's something what can be pseudonymized and still it carries a lot of information. And it's very important, very interesting that this kind of information mining, this stuff is transferable to other markets. And other markets, especially in the West Europe, they are even more strict in regulations of machine learning techniques.
Thank you, Dominik. That was a great answer. And thank you everyone for the questions. I would now like to move on to actually something that is related, and that is from Deloitte and Vladimir in terms of the risks, in terms of the risks associated with the scaled implementation of artificial intelligence in an organization. So I do believe that Vladimir will be touching onto this topic a little bit as well. So handing over to you, and thank you again, Dominik. And Hattie, we have you here as well, and we can see you.
Hi.
That sounds great.
Perfect. Actually, I would like to start because we are here as a team with Vladia. So my name is Hattie. I work at Deloitte as a talent acquisition specialist for consulting, and I am actually very excited to be here because I'm seeking for talented people to join our firm, but also because AI is very, I would say, close to my heart, and I was always very interested in this topic and in the projects that my colleagues do in general. And I closely cooperate with our intelligent automation team, who is one of the best teams in the world regarding all what they do, and I appreciate their work. So I'm here today with my colleague Vladia, who will, I guess, tell you more. Vladia.
Great, thanks, Hattie. I hope everyone can hear me. So hi, I'm Vladia. My picture is there. My face is here. The background is fake. And given the short time that we have, I just wanted to briefly touch what we do. So I'm sure you all heard about Deloitte. It's the Big Four, audit, and so on. But other than audit, we also have the consulting arm that we are a part of. And more specifically, I am from the team that we call now intelligent automation. A couple of years ago, it was called robotic process automation, then robotic and intelligent automation, and so on. But what do we actually do? So we are the ones that help the clients actually implement these AI stuff that the previous colleagues were talking about. So to implement them in a way that makes sense with their business. So we do vendor selection workshops, we do proof of concepts on all sorts of technologies, but always focused on the business process. So we identify potential processes that can be suitable for intelligent automation, or rather we suggest how you need to change, how the organization should change their processes in order to make them suitable. We do the implementation itself. We teach the client how to do them, and this is very important. It's not only, and I'm going to talk about this more later, but it's not only about implementing the AI, finding some cool technology, putting it out there, but how does it work? How do you work with it long term? What's the governance behind this? How do you implement more AI if you want? What's the operating model? And what happens when the AI fails? And that's a big question here. And then, of course, sometimes companies just ask us, hey, and they say, hey, we're already doing this. Can you just come here, share your know-how, tell us, are we doing it right? How can we do it better? What are the gaps in our current, setup, whether that's governance or implementation or the technology that they're using? So in 3 simple sentences, I would say that we really focus on delivering these end-to-end automation solutions. We support the clients in adapting to AI and adapting AI to serve them, for example, through managing organizational change. And we do, of course, do implementing and deployment of intelligent automation solutions across the world. Of course, now, given the hard times that we are all in, across the world, this still means from your bedroom or your living room, but we do have worldwide clients. So yeah, I mean, you can find out more. It's Deloitte, you've heard of it. So speaking of AI, and I have here like a very, very general description, you know, what is software that includes AI? Well, and it's sort of process diagram, you know, so process diagram usually has a start and an end. And at the start, you have some sort of action, and this action is served by code, you know, and it can be anything, application, big corporate application, or something on your phone, or Vault, or whatever. And after that, there comes some sort of decision. And this decision is where we add in the AI, you know. And that's also in the end some code. And based on the decision, we do some sort of action. Oh, I see I have the Czech version here, but okay. We do a different action based on the decision that we made. And the key aspect that, you know, it's so easy to forget once you start, you know, going into the implementation, doing your classification model, doing your neural network, you start to forget what happens when the AI is wrong, you know. And of course, you have a confidence interval. So you say, hey, confidence interval, this is the confidence interval. I'm done. You know, it should work. 97% of the cases, it works. 99.999, it works. But what happens when it doesn't work? And in general, and this is of course a very general story, is you need to have a human, you know, and AI is never, I of course applaud the efforts to work on the general AI, but I feel that we are very, very far from being completely reliant on AI, and there will always be a human here. And this is what managing the risk of deploying AI actually means, is like how to incorporate this human into the loop so that the human is spending his time efficiently, the AI does what you need it to do, and ideally, in an ideal world, no one outside of this little bubble can even notice that there's an AI here or a human. You know, it's transparent, it's a black box towards the outside. And this is something that's actually much, as I said, much harder than it looks at first glance. And that's what we focus on quite a bit in our projects, you know, what we do, because, you know, it always depends on the specific use case, on the specific client, on the industry that the client is in. Because like, as you can imagine, there are different sorts of regulatory requirements on banking institutions compared to manufacturing institutions or Skoda or whatever. And just to make it a bit more specific, you know, so what sort of like simple business currently we are doing processes, you know. So this is not the super cool AI future that the colleagues are researching. This is what's going on now. So the simplest task you can do is, for example, email classification, you know. So you're making a ticket to Vodafone. Hey, Vodafone, you charge me for SMS and you shouldn't have. Please fix, you know. And this ticket needs to get sent to the right team, the person able to help you, because it can be a billing problem, a software problem, whatever. And so we deployed some AI, and it's not Vodafone, sorry, but just imagine it is. Deployed some AI to send this ticket to the right team. And if the AI is wrong, well, someone gets a little bit of spam, they just send it back to the other team. Everyone is fine. There's basically no risks here. We can deploy it, set it and forget, you know. But what happens if we are maybe solving the email of like some client reclamations, you know, they're writing to their bank, why did you block my money? I don't have any executse, I paid for it already. What's going on? Why are you billing me? And then we have the same AI trying to do some same smart NLP stuff, and they decide wrong. So you end up, you know, not unblocking the client's account, or worse yet, the client wants, I don't know, they want another credit card, but instead you block their current credit card, stuff like that. And that's already worse, you know. So the question is, how do we involve the human here to help you, but also, you know, how to make it so that it's not the human actually doing all the work, you know, because in the end you deploy AI to help the humans. And if the AI adds even more work for the humans, well, then why do we have the AI in the first place? And of course, now we have this, you know, loan deferral programs. My examples are from banking because I'm currently working in banking, but they are definitely a applicable to other companies as well. So you ask for a loan deferral, and imagine if it's an AI processing this and you get it wrong, and based on this you go into debt and so on. Well, that's a problem. What's going to happen? We don't know who's responsible for this. Is it the organization? Is it the AI? How can the AI be responsible for something? Yeah, you know, it starts getting tricky and tricky. I notice here, I'm glancing to my left, and I can see that we are slowly running out of time. So take this, please, as a sort of teaser about what we do. I know it's very, very high level, and it's just because it's very, very specific to the individual use cases that we are talking about and individual clients, and I cannot really talk about our clients publicly. However, if you want to know more, we would be very, very happy to chat with you, me and Hati. Or if you're looking for positions, just check out Deloitte.cz. Everything is there. You can contact Hati. Here are the email and the phone number. She will contact me or a colleague for yourself. We are definitely hiring at all positions and not just within the intelligent automation team. So yeah, let us know and let's maybe discuss what we could do for each other. I think I am running out of time, but maybe Sarah will correct me here.
You have done amazingly, and I also really like the bar behind you, and I can tell you that it'd be nice to go to a real one.
Yeah.
Yeah, God. Well, by the way, dear students, and of course, people on this panel, if you want to come to a pub quiz, virtual, but a pub quiz nonetheless, we've got one today at the COFIT after party at 8 o'clock, so feel free to join us on Kahoot. But I do have a question. I had this question, but also someone else from the audience asked it, which was about, you basically spoke about the whole like action and reaction feedback and incorporating these methodologies into the corporate. To what extent are humans removed from the automated decision-making? Because automated decision-making comes across quite a lot. Obviously, AI can automate a lot of processes, but then people often get scared that they start basically losing agency and that they start losing decision in that decision-making process. How do you balance that, both from a technological perspective? So like at what point do you actually stop removing the humans? And also from a psychological perspective. So explaining to the people, no, AI won't replace you. It's just making your job a little easier.
Okay, it's actually a pretty nice question. I'll start from the last bit when you ask how can you dissuade these fears that we come to take your jobs away. So in the end, because what we do here, we focus on very routine stuff, not interesting stuff that humans don't actually want to do. So of course, the initial reaction is always something new is coming. I'm afraid they're going to do some work. That means I don't need to do the work. What's happening? But what happens in reality is that there's plenty of work for these people to do that requires human thought and that requires something that AI is currently not capable of, you know. So instead of writing data from a paper to an Excel file, from an Excel file to SAP, instead of that, you can discuss, you know, maybe analyze, hey, which way should we train our AI model? How should we improve this? How can we, I don't know, teach our vendors to send better invoices so that we can process them automatically? So, and once people realize this, and this is a process, and it's also part of what we do, you know, because the initiative, hey, let's automate, it comes from the leadership, but in the end, it impacts the people who are actually performing the job. And the part of our role, or even a big part of our role, is communicating what this change means for the people actually doing the work that we are sort of, I don't want to say replacing, but we are giving them a helping hand so that they can focus on more interesting stuff, you know. And to take a step back to your question, what are the risks and when is the human going to be involved? Honestly, and this is my personal belief, but the human should always be involved in the end when there is a time to make a decision. So yeah, we need to look at the technology, see what the technology can offer. Of course, we can, you know, decide what happens, and this is what I was trying to say on the previous slide, you know, if we make a wrong decision, how big of an impact does it make? And this bar is going to change, and that's going to change like where humans are involved. But in the end, humans are always going to be involved, at least until you guys on FIT finish the general AI topic, and we can just, you know, roll up into the singularity. and move into the bar behind me. I hope that answers your question. It's pretty broad, so my answer was equally broad.
No, that sounds great. And I have one more question about biases. Again, it was something that was maybe asked to the first speaker in terms of Cisco, so feel free to react as well. But the specific question is, how do you avoid introduction of human biases, for example, hatred or like various like unpleasant human features into the AI algorithms when it learns on data produced by people who are biased a lot? And what could be further done in that area, basically in order to remove those biases, but at the same time, not to bastardize the science behind it. So that's kind of an open question for you, but of course, if anyone else wants to react as well and feels strongly about it, feel free to put your hand up.
Tough questions today.
I'm so sorry.
No, that's fine. I'm glad for the discussion, actually, because, yeah, I would say that the science is there, but the risk appetite is not there yet. So yes, people are aware that hatred and prejudice and stereotypes can impact the human decisions and can therefore impact the AI. And this is why when you start looking into the more like large scale complex deployments rather than proof of concept and pilots, and specifically for this, you know, I worked on a case in a bank in Western Europe where they were doing loan approvals by AI. So it was in the end a pilot, but the human was the one who was doing it independently of the AI, and they were just comparing. So I would say that the science is getting there, but the companies and the businesses do not yet have the risk appetite to approach these harder topics because they do not have the frameworks, the methodologies, and the internal confidence to deploy something because, you know, there's a lot of public talks around this. It's not just us here. This stuff that people talk about, and companies are, and especially once you go into the more regulated industries like banking, insurance, pharma, they are definitely very conservative and risk averse. So they do not want to add in something that's gonna put them in the forefront, and bad publicity can also sometimes be bad publicity, you know. So yeah. Short answer, science is there, but the business is not yet ready for it, my opinion.
Yeah, thank you. Thank you very much, Vladimir. And thank you for the pragmatic answer.
Sure.
So we had heard from Deloitte, and I would now like to move to PwC, namely Aleš Nemochovský and machine learning versus dirty money laundering. I love it. We've got very sensationalist titles, very juicy. So students, if you are watching, please use the opportunity to ask questions. It's the last talk of COFIT, so make sure that you get involved. If you want to speak to the companies individually, then go to the Together platform to their individual stands or Slack. I'm just going to ask Aleš quickly, is it in English or Czech, just so I know?
Yeah, I prepared the presentation in Czech, but if you prefer English, then I can try to switch to English.
If English is okay with you, then that's great. We've had a couple of hybrid presentations like this already, so I think we can freestyle it if you're happy with that. So you can go in English. Thank you.
Okay, I'll give it a go. I was rehearsing the presentation in Czech, so let's see. So, hello, my name is Aleš Nemochovský. I work at PricewaterhouseCoopers, PwC, and I'm gonna try to how we're using machine learning in anti-money laundering. So I hope you see my screen.
Yes,
so I've broken down the presentation into two major sections. In the first section, I'd like to give you a bit of a context, since most of you are probably not familiar with this field. And in the second part, there's got to be like 4 minutes. And in the second part, I'd like to introduce you in what machine learning algorithms we're using in the field. So that's going to be about 7 minutes. So a brief introduction of the company. So we are, again, one of the big 4 consulting companies. And we are in the advisory section of the company, which means that we are doing consulting.
but we're doing asset-based consulting. We're trying to do so. We are somewhere in the middle between like a traditional consulting company that's trying to sell people and a traditional software house that's trying to sell licenses of software products. So we actually do both. We are very close to the clients and we have our own products. You can see a screenshot here. It's completely running in Azure, in cloud, and it's clients input their data there, and we're running models there and then presenting results to them. So I'm in the financial crime practice. There's roughly 15 people here in Czech Republic. We're serving mainly in the Central and Eastern Europe. So that's mainly countries like Latvia, Hungary, Slovenia. But we also have many clients outside of this region, for example, in Australia, Luxembourg, Pakistan, or New Zealand. So the very close team to me is roughly 3 or 4 people at the moment, and we would like to expand it. So if you like the presentation, feel free to reach out to us, and maybe we can discuss what you liked and what are your ideas. So briefly about myself, I have studied at the Czech Technical University some 13 years ago, and then I studied at the Erasmus exchange program at Coventry University in England. And an interesting thing is that both of these universities share the same color, and they also use in their logo an animal that doesn't exist. So I really recommend going for an exchange program. It doesn't matter if you're going to the south, to the north, to the east, to the west. All students have just brilliant experiences. So I highly recommend going somewhere. I've been working so far mainly as a data scientist. I came to PwC from Oracle, where I've been developing a new autonomous machine learning platform for the new Oracle Cloud. And currently I'm leading the analytics practice at Financial Crime here in Czechia. So what is money laundering? Basically, it's trying to legitimize illegally gained money. So this money usually comes from corruption, terrorism, or drug sales. And you can think of it as, for example, if you have such a source of income, and so let's say you have 10 million Czech crowns and you want to buy something nice for it, let's say an apartment in Prague, then you can come with the money, because it's usually in cash from these sources. So you can come to the real estate agent and say, hey, I'd like to buy this flat and I'm paying in cash. They will reject it. They cannot accept so much cash. So you have to somehow transfer the money to the banking system. How to do it? There are multiple scenarios, maybe 100 scenarios how you can do it. Here is an illustration of one of them that's called structuring. So basically, the criminals try to break down the sum of the amount of their money into smaller chunks, somehow insert it into the system by, for example, inputting cash in small amounts at the bank branches, or through restaurants, through shops, through casinos. And then they need to, again, aggregate the money on a different account, and because only then they can finally buy something like a car or an apartment. So now to machine learning. Have the obligation to monitor transactions of all of their clients. That's imposed on them by regulators, and this is how a typical monitoring system looks like. So it takes transactions from a warehouse, processes them based on some expert-based scenarios, and then displays alerts to investigators. These investigators research the alerts and using some additional data from the bank CRM, make a decision whether this is really something suspicious, then they report it to the regulator, or otherwise they close it as a false alert. The problem with these systems is usually that the scenarios that are defined by regulators are not very well optimized. So they generate large amounts of false positives, so large amounts of false alerts. So this means a lot of costs for the banks because they can have tens of investigators and they are not cheap people. So how can we apply machine learning in the system? So I have highlighted a couple of ideas here that we either do or planning to do. So what's interesting is that each of the model is very different. So we don't have just one model that we try to apply in very similar context. All of the models are very different. So the first opportunity out of the four is clustering, and that's customer segmentation. So in this, the volume of the data is roughly millions of customers. And what's the reason? The reason is that the scenarios are tuned differently for different groups of customers. So you can imagine that it doesn't make sense to set the same thresholds for people like us, for normal individuals, and for VIP clients who spend large amounts of money do high volume transactions. So for this reason, different scenarios are tuned for different segments. And the current practice is that the segments are defined using static characteristics that the bank has, and as a result, the segments are not very homogeneous. So what we are doing, we are helping the banks create better segments. So we are using machine learning. We define something like 100 or 150 features. Then we do dimensionality reduction, and then we run some clustering algorithm. Currently, we use k-means, but we would really like to use something better. So you can help us with implementing some distribution-based model or some probability-based model. That would be great. Another option is classifying the alerts. So we can classify the alerts that the investigators see, for example, into low risk, medium risk, and high risk. We can, for example, close the low risk alerts right away automatically and let the investigators focus on the high risk and medium risk alerts, because these really require a human brain to be investigated, and they are cognitively difficult decisions to make. So let's keep this for the human for now. And so this is a traditional classification task. Usually the magnitude of the data is tens of thousands or hundreds of thousands of alerts, historic data. So that's already labeled that we can use to train a model, something like a tree-based or tree ensemble, something like this. Another option is that the so-called red flags that the regulators publish, they come in PDFs that the regulators publish. And currently what we are doing is that we go through the PDF files and extract the red flags and categorize them into various classes. This is quite a manual process, and we're working on automating this with PwC Australia. And so basically there's a problem that we don't have too much data. We have only hundreds of these red flags. Maybe we will have low thousands of these, and we are trying to classify them into 10 categories. So so far, because we don't have a large amount of data, we're using latent Dirichlet allocation to reduce the dimensionality, and then we're using auto-sklearn to automatically classify the data and choose the best estimator. And the last opportunity that I have here is monitoring the transactions without the rule-based systems altogether. looking directly at the transactions. So in this case, the magnitude of the data is very interesting. That's tens of millions or hundreds of millions of transactions. And this is a very interesting task that I think we can look at it from three perspectives. I think either we can look at each transaction individually and perhaps train some autoencoder to learn like normal behavior in the segments and then detect anomalies from these traditional behavior. A second way to approach this could be looking at sequences of data. So looking at one company at a time and looking at their transactions as a stream of events. And so taking into account the time dimension of the data. And here I think we can use hidden Markov models or maybe some recurrent neural network to, again, learn some traditional behavior and then detect anomalies from this behavior. And the third task, the third perspective of looking at this task is seeing this as a graph task. So the accounts being the nodes in the chart in the graph, and the transactions being the edges between the nodes. And then we can look for patterns in the transactions, and again try to find patterns that are outside of like standard behavior in the segments. So that's all from me. Thanks for your attention, and we have a stall here. So if you found something interesting in this presentation, we would be really keen on discussing it further, and we have many opportunities here at PwC. So thank you.
Thank you very much. And I actually have something about anomaly detection, which I always found fascinating. Because you have to basically find patterns and define what normal behavior is, but also sometimes abnormal behavior, the examples can be very sparse, like they don't have to happen that often, or they may not even be identified as abnormal because they might be only slightly deviating from the norm. What is the effect of cultural differences to this? Because obviously, like, we handle money in different ways. There's a lot of changes happening between, for example, like microtransactions, or how like individuals started like investing in different ways now. People are traveling a lot less. So COVID has basically like made everything abnormal because it changed behavior so drastically of so many people. How has that affected the way that you detect anomalies and then design those algorithms?
Yeah, that's a great question. So I think there are two aspects that you mentioned. First being the geographical aspect. So that's a good point. I think you can't have one autoencoder or one estimator for all types of people. It again makes sense to differentiate between them using some segmentation that could help. And that's actually what we do. And yeah, so that's even, you know, distinguishing between small companies and large corporates. Again, you can have one estimator to distinguish anomalies between them. And the time aspect, I think, yeah, that comes down to deployment. And if you just deploy a model and let it be, then that's not a good idea at all. You need to monitor it, and you need to be very careful in what you're measuring, how you're measuring, and whether you have concept drift, and really either have online machine learning and approach it this way, or regularly retrain the model, especially in like times like these when things change rapidly.
Yeah, I actually remember the time when I was still living in the UK, and I was with an unnamed bank, and they had this system change where before you traveled somewhere, you had to let them know internally how long you're traveling for and where you're going. basically to inform the algorithm, I'm flying to America, everything's fine, no one stole my card, just so you know that I'm like traveling. And then they did a big overhaul and you no longer had to report that, but they didn't let the customers know. So the customers still started reporting it, and it actually confused the algorithm even more. So it was a very, very funny time. Not funny for me because they blocked my card when I was in America, but that's ancient history. But it's interesting to see these changes play out in real life. Aleš, thank you very much. You were great, and you gave us a great presentation in Czech and English simultaneously, so that was awesome. I would like to now move on to the next speaker, who is Jan Beam from Datamol, who'll be talking about calf to cow. We then have Veronika Maurerová from H2O, and finally Wojciech Vančura from Recombi. Please ask questions if you have them. We have a couple in the chat that I'm saving for the next speaker. So keep asking them. I'll try to put them to good use as they come in. And now, Jan, it's all yours.
Hi, everyone. Thanks, Sarah. I'm Jan. I come from a company called Datamol, and I would like to take you along on a journey throughout one of our projects. And if you find any of the parts interesting, then we would definitely love to hear from you, and maybe we can actually collaborate on that in the future together. So a little bit about Datamol. So we are still pretty young as a company. We were born in 2015, and we started a journey of helping industrial companies with their data and AI-driven products, services, and so on. And I personally joined not even 2 years ago. And what I really like about Datamol is that the company really thinks about the projects that they carry out, and those projects, they don't need to make sense only from the business perspective, but also from the human perspective. They need to tick all the important boxes like ethics and so on and so on. And I really like that. Okay, so calf to cow, bit cryptic name, but for those of you that don't have the regular farmer's vocabulary, calf is in Czech tele, and then I will be also talking about heifers. And heifer is jalovice. So that's just to refresh some of the English words. And let's go into that. So let me start with some identification of an opportunity, like where we can help farmers to care better about cows. So this is a cow life cycle. So here it gets born. It's called calving when it comes to cows. It's very small. Then it moves to group housing. That's one of the important and interesting periods for us, because suddenly it's not being taken care of individually, but in a group. And then the farmer usually doesn't have much time, and so on and so on. And then another very important bit is insemination that has to be done within very carefully chosen time period. So the cow is ready. Well, the heifer is actually ready. And then once it becomes pregnant and gives birth, then it becomes what we call cow and gives milk. Of course, this, by the way, works only with dairy cows. Meat cows are a bit different. Okay, so the problem here, the calves are very vulnerable when they are small. They are like human kids, so you have to take care of them very carefully. Otherwise, there might something happen during their development, and they either won't have the performance or they won't be able to give birth, or so on and so on. And another bit is that the heifer must be mature enough to fit the calf in, and at the same time, you don't want to do it too late, because then you're spending a lot of money on having a cow that doesn't actually do anything for you. Okay, so how do you actually start an AI project? Of course, with standard industries, usually you have to start from hardware, because most of the companies are still not used to do data-driven products. So you have to collect your data somewhere. Then you have some pipelines and some data processing. And of course, at the end, you have to close the loop and you have to get the user in there. So you have some user interface where you can demonstrate the data and show what you actually got from there. So starting with hardware, in this particular project, our partner, Lely, which is a company in the Netherlands that does farm automation and robots for farms. They created this little piece of hardware. It's a 3D camera that senses calves and heifers. And we get plenty of data from there. Additionally to that, you have some tags on cows that can actually tell you whether they are active, whether they are eating, what they are doing, some water flows, some climate monitors, and so on and so on. So next, you move to actually some image processing. That's one of the really fun parts, I guess, for most of the people. And here you start hitting the real world. So first you have to do some body segmentation, and you realize that cows are not very civilized. Like, they are pushing each other and they are trying to get into the machine all at the same time, or they get interested by something and so on. But ultimately, we usually manage to get all the features from them. And there are some other interesting problems like straw correction. So the cow doesn't actually know that it wants to be measured, because it will be helped in that way, and the care for it will be much better. So it brings a lot of mess around, and at some point it might actually increase the height of the straw quite significantly. So the cow appears to be smaller and smaller. So you have to care for problems like these. And of course, some camera calibration, if it gets knocked and it moves a little bit, or, you know, some other interesting problems, like if there are a lot of flies and they make the camera dirty by simply shitting on it. So yeah, you have to handle real world. And when you finally get the data from that, you can work on some models. So you want to get from data to some decision or advice for the farmer. So we take all the data from the cameras about height, about where certain body parts of the cow are, how big they are, how far they are from each other. So, you know, like hip bones and spine and so on. And then you can actually tell how high the cow is, probably, because everything is a bit blurred in the real world, but you have to get around that. You have to do some smoothing and filtering, and eventually you might be able to actually tell farmer something interesting. And we succeeded in that. That this is very important for them, because they know whether the cow is growing properly, whether it should be fed more or no, and so on and so on. And of course, you can't really do that on average for any cow. You should usually take the farm into account, because each farm has completely different management and it can mess it up quite a bit for you. So you have to take a look, how does it compare to the particular farm? Another bit that you can do with such data is, for example, detect health issues, both from the growth, but also from milk consumption. So as humans, cows are very similar, you know. If they are sick, they might stop eating because, I don't know, they have some kind of stomach ache or something similar. Actually, the diseases with cows are called a bit differently, but I will stick to the human names so we know what we are talking about. And then there comes the advice about insemination. So there is a patent pending here, but roughly you can detect whether the animal is in heat and whether it's high enough, whether the bones are all shaped up correctly, and whether it's satisfied some minimal age. And then you can make a decision whether to inseminate or not. Ultimately, all this information needs to get to the farmer. So it gets to this beautiful UI, so he can see healthy cows, calves, heifers, whether they are in heat or not, and so on and so on. And here we manage to actually help them quite a bit. So we provide some performance data on the growth of cows. We detect health and development problems. We can advise on insemination. We can tell farmer how much milk the cow is gonna produce, and so on and so on. And of course, all this needs to be running somewhere, and it's not so easy. So this was more work of data scientists and maybe some machine learning engineers. And then here comes the background of all of it. And you can see it's actually quite a complex system. So somehow you have to collect your data on the farm, which is a problem on its own with these cameras and flow meters and so on. And then you have to get them to the internet. And once again, you hit the problems of the real world, because some farms are not connected to the internet. So you need a farmer to actually put it on a USB stick and drive somewhere where there is internet and upload it and so on. And of course, then all the data need to be put somewhere. You have to get them into your models. You have to put together data from all farms from around the world, create some reporting and so on and so on. And ultimately, you show it to the user. So there's also loads and loads of data engineering and UI work and so on. And that's why we are actually looking for pretty much absolutely anyone, from people that are able to talk to the business, data scientists, engineers, ML engineers, whoever got excited by this project. And I can tell you it's a lot of fun to work with the real world problems. Then we are definitely looking forward to talking to you, and hopefully we will work together at some point. So any questions?
Thank you very much, Jan Beam. Yes, I have questions.
Go ahead.
Sorry, I always have questions, but there's also one from the public, so I'll give that space in a little bit. And it actually ties in a little bit. I read this article, it had the worst title ever. It was "We're moving into using AI in animal husbandry." So it was a great pun. Everyone was very happy. But it spoke about the different applications of artificial intelligence in helping agriculture, but also just the welfare of animals, monitoring the temperatures of beehives, farming insects, repairing aquapods for salmon, like all that stuff. And it makes me think about the connection of nature and technology. There's really annoyingly in society, there's this like Cartesian dualism of we've got the trees and the bees, and then we've got the evil robots, and those two things do not go hand in hand, when actually the digital world can help the natural world so much, and vice versa. Like we learn, we were talking about the good AI research in terms of artificial general intelligence. We inspire directly from things like swarm intelligence that we can see in fish and birds, or like principles of evolution to design artificial intelligence algorithms. So the nature and technology link is very, very strong, but the public often doesn't see it that way. So could you actually maybe give a bit of a perspective, and this leads into the question that was asked from the public about the influence of computing on the environment, that actually the environment and AI can coexist, and that AI can help make the environment better and protect species, protect animals, protect the environment, and that it's not all the tragedy that Bitcoin is going to destroy the entirety of the Amazon rainforest, or that the Terminator will destroy every living thing on Earth, because unfortunately that's sometimes the way that the rhetoric goes.
Yeah, okay, so especially like what we are working on, we are mostly actually working on projects that care about animals' health and well-being, because that's something that wasn't really done before much, because of course there is a very easy way how to milk a cow very effectively. You just do it all the time, and if it dies, you get a new one. So I'm pretty sure that there are plenty of ways where AI can help with these issues. Of course, there is all this debate about energy and how to get your compute, but I think the technology is there, right? Or it's getting there at least. We have much more efficient CPUs, GPUs. Every single year their performance per watt increases incredibly. And I'm actually, because my background is in science, and I even did one project with the Czech Academy of Sciences on the tokamak. I really believe that we will solve this whole energy question once we have the fusion reaction. And I actually believe that's coming soon. And that's the ultimate solution to all this. And then you can mine as many Bitcoins as you want, because it'll be all clean anyway. So
I like it. Thank you very much. So I hope that the audience got their answer. I definitely got mine. Thank you, Jan Beam, for sharing this. I wanted to say some kind of pun on cows, but I'm brain dead. I can't. But it was great. It was very motivational. No, sorry, no, that doesn't work.
Cheers. Great being here.
Thank you. And with that, I would like to move on to H2O AI, specifically Veronika Maurerová. We already had a great talk last year, and she's going to follow up on that from last year's COFIT, specifically with machine learning and direct marketing. Veronika, it is all yours. Please take it away. And we can see it. We can't hear you, but we can see the presentation. Oh, sorry, I think you need to unmute yourself. Sorry.
I'm sorry.
That's all right. We can hear you now. Thank you.
Oh, great. Hello, everybody. Thank you, Sarah, for your warm welcome. First thing I would like to say, I love your enthusiasm for machine learning, for AI, for this event, and I'm happy to be here too. I'm an absolvent faculty of information technology, and currently I'm working for H2O AI as machine learning engineer of H2O free open source platform. Let's start with my talk. First, I would like to introduce what H2O AI do, and then I would like to very shortly speak about using machine learning in direct marketing. The main goal of H2O AI company is to democratize AI, which means to access machine learning and AI to everyone, from individuals to universities and industry. So we are mainly developing software, but we are also building a strong community, and we like participating on projects which are non-profit and have a social impact. Briefly, H2O AI is a company developed in the US. Today, it has more than 200 employees, and the company is global. So the headquarters is located in Mountain View in California, but we have also offices in Prague, London, New York, India, and Sri Lanka. We are cooperating with Czech Technical University for the second year. Our main objective of the cooperation is to show how fast growing AI company works and proposes meaningful assignments for students. And I would like to mention here 2 successful projects from last year, where we implemented 2 new very interesting algorithms to our open source machine learning library with students from Faculty of Informatics. We posted a blog post where you can also find links to the students' project and code, so you can imagine what is possible to do within cooperation with us. This year, students could contribute to open source and closed source too. Don't hesitate to contact us if you are interested in some assignments. We are all assignments listed in Notion, and you can also contact us on this email. And I would like to also invite you to our mini predictive hackathon, which will take place tomorrow during the COFIT event. And don't be afraid to join even if you are not a machine learning expert. I will guarantee everybody will be able to create a simple predictive model at the end. And our awards are nice, I think, but from my point of view, the most valuable thing is to learn something new. So please join and don't be afraid. And now let's move to the second part of my talk. When I was thinking about the topic, I decided to show some practical usage of machine learning. And I'm sure that everybody here had an experience with direct marketing in the past years. For example, someone calls you to offer something, or you definitely got an email with some super exciting discount after you buy something on eShop. Or I'm sure the most from you having at least one customer card in your wallet. So you definitely know this topic, but maybe just from the customer side. And I would like to explain one machine learning technique, how sellers could select right people to send email or call them with an offer. Sellers can offer discounts to every customer to keep as many customers as possible, but it is very expensive and it could not have any effect. They can be more clever and select only the customers which are the most likely profitable. And that is what direct marketing very shortly is about. But how effectively classify which customer is worth the effort? Seller would like to classify 4 types of customer. In general, already happy and satisfied customers, and lost causes, where the best thing is to do nothing for them to save money because they are already decided. Important is to find sleeping dogs, which will be very angry if they got some offers, and the persuadables, which are the seller target. But it's really hard task to classify these 4 types of customers because you never get to know the real reason why the customers accepted the offer or not. So you have to prepare and analyze data differently than use just simple classification model. So let's split customers randomly to the 2 groups, treatment and control group. Treatment group got the offer and the control group didn't. And for some time interval, the data about acceptance of the offer is collected. After that, the predictive model is created, but now 2 pieces of information are important here. If the customer is in treatment or control group, and if he or she accepted the offer or not. That is the main difference compared to the classic classification model where only the target is important. And also, prediction and the metrics are different than for classic classification. I don't want to share more details because it's lots of math behind, but just to show how it's different. The goal is to predict the probability that customer will respond, and the prediction is calculated as a combination of treatment and control prediction, usually as a difference, but there are also other possibilities. To select the right threshold for targeting customers, the uplift curve is useful. It's similar like receive operating curve in classic classification. And very quickly you sort all customers by predictive value and calculate the lift metrics. And then plot these values to the graph. And for example, on this graph, the peak is around 50% of customers. So these customers you want to select and you want to send them offer. This approach is called uplift modeling or causal inference, and there are some cool methods or tools you can use for it. First, you can use traditional models and use the group as the feature, but this is not too accurate, and you are not able to consider, for example, negative treatment impacts. Second thing, there exist algorithms adapted to learn and predict directly with different groups. These are very accurate, but it's limited only for using random trees or regression, because you cannot use, for example, gradient boosting trees or neural nets because they are not able to adapt it to predict with the different groups. So finally, it's usable, but it's usually very slow. So third possibility is use meta learners, where you transform group and target feature, or train model for treatment and control group separately. And in this case, you can use traditional models as XGBoost or neural nets and whatever you want. This approach is usually really fast, but for some problems you are not able to find an accurate solution as with direct uplift models. And this topic is also close to me because I'm currently implementing direct uplift trees to H2O free open source platform. So it will be available soon in H2O, but there are other implementation already available for Python and R. For example, Uber Group is developing the causal ML Python package, where you can train direct uplift models as well as meta learners. So I hope you learned something new and enjoy this presentation. Thank you.
Very much so. Thank you very much. It actually makes me think, we discussed this in a couple of previous lectures, that basically the world of technology is changing so much and the employment market is changing so much. It's really important to have this democratizing platform where everyone can plug in, and where you can learn what the hell is going on. You can see the transparency behind it. I remember, for example, in the last startup that I was in, actually being friends with the IT people and understanding what the process looks like and what they have to go through in terms of process before they can deploy anything. It changes the whole business system because and the sales process, because suddenly you know what you can promise, what you can't promise. It helps manage expectations, etc. So what do you think is the number one thing that maybe businesses are doing wrong right now internally in terms of sharing this technological know-how? I'm sorry, I know I'm asking crazy big questions, but just from your perspective as Veronika, or the reason why you're in H2O and why you're so passionate about it, what do you see as the biggest added value that you can bring to businesses? Is it the democratization element or is it something else?
Yeah, that's definitely democratization. But, yeah, the reason is that people need to educate, and it's really important to show that AI is not just crazy maths and lots of it's not such magic as it looks. So it's really important to show that everybody can look into, everybody can learn machine learning and understand what is doing in it. And yeah, the open source is the way, I think, and it's cool that everybody can use it and look into and maybe be inspired. And yeah, and I think the companies should definitely educate the people now. And
yeah, and speaking about companies, maybe one more quick question. I see a lot of reskilling taking place. And one of the things that people are afraid of with the dawn of AI is that people will lose jobs to AI or to automation, and that they won't be able to find new ones. But actually, a lot of the statistics show that AI will create almost twice as many jobs as it will replace. There'll just be more interesting jobs, and it'll just automate the manual, boring stuff that we don't want to do anyway. But people are scared of that reskilling because they don't see what actually happens under the hood with machine learning. Again, for you, what is the most effective way how to encourage people to reskill? Because people right now are scared because there's a lot of also AI elitism that says, if you're not from a technical background, please piss off because we're a bunch of very highly elite AI people and we don't want to talk to you. Obviously, that's not the case with this group and with the COFIT ecosystem. It's very, very open, but not everywhere. So how do you think that the companies should communicate this, that everyone is welcome and that reskilling is the way forward?
That's a really hard question.
Oh, yeah, yeah, sorry.
You are incredible. You just it's a really hard question for everybody.
Yes, basically,
that's fair. That's fair. Yeah, it's about communication, about the community around the AI. I really like the idea of Prague AI and an idea of the translating to evolutionary of AI course to everybody in Czech in the languages which are available for everyone in the world. So yeah, the education, maybe yeah, it's also important to show in media and at schools from elementary schools to high schools that there are some new technologies which are very useful and open to everybody. So education, I think it's the most important. But yeah, it has to start from schools and then move to companies and then it will be better, I think.
Yeah, you're absolutely right. And given that I did just ask a very difficult question, like your answer is completely spot on. I've been on so many panel discussions lately that have been saying, "Oh, the education system is broken." It's like, yeah, well, no shit. Yes, it is broken. But it's exactly like being open-minded and multidisciplinary and not being an educational snob and saying, yeah, if you want to know more about technology, you can. It's easy. Like you literally just need a connection to the internet and a computer and you're fine. And you can find out so much about things like machine learning and AI that until very recently were a bubble in its own. And I think that this open approach is very important, and H2O is doing a great amount of work in that regard. So thank you, Veronika, for your insights. We have the last, but yeah, no problem. Thank you. And see you next COFIT again.
I hope.
And we have the final speaker for not only today, but for the entirety of COFIT lectures. Oh my God, momentous moment. Wojciech Vančura, no pressure. Wojciech Vančura from Recombi. Recombi is one of the children of Pavel Kordík, doing great stuff in terms of recommendation algorithms, kicking ass globally, even beating some recommendation algorithms from huge corporations like Amazon, and really leaving a global mark. So I'm really excited about what Wojciech has to tell us. And I think recommendations beyond expectations perfectly encompasses that spirit. So without further ado, Wojciech, take it away. Great to have you here.
Hello, everybody. Thank you for inviting me to this talk. I will be talking about industrial PhD with Recombi. And it's mostly based on my own experience because I'm a PhD student on Czech Technical University, Faculty of Information Technology since September. And I'm enrolled in this program. So everything I'm talking about is my own experience. It's not just marketing. And I want to start with short introduction of Recombi, of our company, and why you should join our company. And Recombi is a startup, and it's a startup founded by former students, former PhD students, and it's a startup in a really interesting phase of its lifetime because it's experiencing an exponential growth of its customers and revenues. And it's really interesting to experience startup within this phase on your own. So this is basically what I found most interesting on Recombi. And Recombi provides recommendations as a service. This is really interesting because there are not much attempts to do that. And I want to tell you about what's a recommendation and what's recommender systems. And I believe everybody personally was involved with recommender systems because every online shopping, every e-shop, every online platform like Netflix or Facebook or Twitter, various domains has extensive recommender systems. You may be familiar with this box recommended for you. This is typical recommender system. It collects information about users and items and interactions between users and items, and it provides recommendations. And since I was clicking on some cakes, it recommends me a cake. And so I believe this recommender is working great. And why to study recommender systems? This is really interesting topic. Okay, so the first reason for studying recommender systems is that it's a real world problem. And when I say real world problem, I mean that there are like hundreds of clients, of customers in Recombi. And when you design a new model or a new algorithm, you can deploy it in production right away and do some A/B testing on it. So it's really interacting with a real life, with real humans. It's not just that the same situation as in computer vision, for example, where you have offline data set like NIST or ImageNet, like was discussed before by our colleagues. But you have real people who are doing purchases and viewing pages, and you are recommending products to them. So it's a really interesting task from this point of view. The second reason I think recommendation is very interesting to study is that it's a really complex task, and it's not just data mining like the classic recommendation, but this task involves computer vision. You can have app in your phone, and for example, you can take a selfie and want to recommend the user glasses based on the selfie, and that is a recommendation task, but based on computer vision. So it's pretty complex. You can involve natural language processing, and I encourage you to do an experiment. Just ask your iPhone, "Hey Siri, recommend me a restaurant," or "Hey Siri, I'm hungry," and they will, the phone will recommend you nearest restaurants based on their rankings. So it's not just something on the web page. It's really complex task. And there are many more AI categories which are needed to study to build a really good recommender system. And the third main reason is that research of recommender system is ahead in some topics, and one of that I want to mention is ethics, because many challenges emerge when you start recommending items. And for example, in news domain, if you have a serious news server like CNN, and you implement a recommender system that will be optimized to increase the click-through rate, so users are clicking on the recommendations, you will find out that the most clicked recommendations are the boulevard news, are sex, sales, it's like that. So when you optimize only the click-through rate without considering some ethical issues, you will convert the serious news server into tabloid, which probably the customer don't want. So it's really necessary to consider these topics. And if you look at the program of biggest conference in recommender systems called Rexis, which will be held in September in Amsterdam this year, there is one whole track for ethical aspects of recommender systems, for the biasing and stuff like that. So it's really interesting, and I believe that the rest of the community will be dealing with these topics so very soon, in a few years, but the recommender systems are dealing with them right now. So this is really interesting to reason to study recommender systems. And why PhD or industrial PhD with Recombi? Well, the main topic is that PhD is sponsored by Recombi. The Recombi is sponsoring university, and a university is sponsoring your research by a grant. So which is really cool, because you have money for your research. That's nice. You have the possibility to A/B test your new models in production on live users. That's really cool thing. And you have support from other researchers in Recombi. in Recombi laboratory, because the founders of Recombi are former PhD students. They have really big understanding for the problems that PhD students are facing, which are really great. And I don't know how if we have time, I prepared one case which we are currently researching, and it's next basket prediction. And next basket prediction is a task to predict customers' next purchase, but the whole purchase, and probably getting deliver his purchase just before he orders that. So we know that he will order something and we are ready. And when he ordered, we will just deliver in the right time. And this task is extremely hard, and I'm talking about it because we are currently holding a challenge or competition in the ADM class. So if you are enrolled for this class, you can definitely participate in this challenge. If you are not enrolled in ADM class and are interested in researching predictive delivery, just contact me or Pavel Kordík, and we will find a way how to get you involved with this. I don't know if we want to get into technical details of this. There are some real case from the company called Bofrost, which are dealing the frozen food in Germany. And so it's there are some items from their catalog, and we have history of user purchases, and we are trying to predict the next purchase with deep neural network. The first step is to embed the basket, the purchase, the whole basket into some dense representation in some vector space, and then run a prediction with LSTM network in this vector space, in this dense vector space, and make a prediction of the next basket, and then decode this prediction into baskets. So that's it. We did have some promising results last year in this competition, and we are holding it again this year. So we hope we will get some interesting results, and we will be able finally to do predictive delivery, which is not currently possible. So thank you for your attention, and I'm happy to answer any questions.
Thank you so much, Wojciech. I have a couple of questions, and it's basically around not necessarily randomness, but the unpredictability of human behavior. And it actually kind of like links a little bit to anomaly detection that we were discussing at the very beginning. So let's say that I order certain things like milk, eggs, I don't know, minced meat, because I like to make sekana. But then I'm having like a party, or I'm having a dinner with my mum for her birthday, and I want to order champagne and chocolate. To what extent can the algorithm basically deal with this wanted randomness? So I understand that if I'm, for example, a vegetarian and I never order meat, and suddenly the predictive basket brings me T-bone steak, then that is like an unwanted anomaly that is not desired. But then sometimes humans are unpredictable creatures. So how do you deal algorithmically with this unpredictability?
This is really excellent question, and this unpredictability is extremely hard. And I can tell a story about I was deploying my first model, and it was for one company in the US, and I trained this model on some data, and the recommendations look pretty good. But there was an issue, because when I was training the model, there were some gay pride festival, and everybody was buying those rainbow cakes. And I have this cake here in this presentation. So everybody was buying cakes like that. And my model learned that these are very popular models, and I deploy it, and my model was recommending these cakes. But the Pride Festival ended already, and there was Thanksgiving. So everybody wanted turkey, but my model was recommending rainbow cakes. So the unpredictability and randomness is really, really, really tough task. So,
thank you. Yeah, that's a very good example, and that actually leads on to my question about. I wanted to ask what is right and what is wrong, and like objective morality. But we'd be going into like Aristotle here, and I don't want to like completely kill everyone off at the end of the day. But it relates to when you were mentioning basically clickbait and the fact that sometimes, you know, sex sells, like people, it's popular, but people enjoy that. And sometimes, like, to what extent is the censorship or the kind of saying, oh, well, this is a clickbaity title, so we have to somehow like address that in the way that we program the algorithm. In terms of cultural differences and like what is considered right, what is considered wrong, what is considered fake news, what is not fake news, what is just like a popular article that people want to read because people are bored and they want a bit of, you know, cheesy media. To what extent does the developer or the company have the authority to step in and say, we need to police this particular like behavior trend? Because it gets very complicated when you get to something like elections or like the way that society is structured and what you allow to get to the people and what you don't. Where does that lie? Because, like, for example, I don't know, here in the Czech Republic, we might like some type of content and we might consider that objectively good, but somewhere like Vietnam, that measure can be somewhere completely different. So as technology gets more global, as all these new cultures come together, where do you start and where do you end in terms of policing the type of content that gets out there?
You have excellent questions, Sarah. Not easy.
I'm so sorry.
Not easy, not excellent. Well, this is really interesting because it's always fight between algorithms and the editors. And if you have some serious news, there are editors who think they know what their users want to read, and they have their own opinion on what should be displayed on the front page, for example. And then there is an algorithm which thinks something different. And it's always a fight between editors who want to kill us and us who want to survive in this environment. So we are developing some tools for these editors to boost some type of content and have some control over the algorithms, which is probably the way how to deal with this issue.
Thank you very much. And I think that you beautifully wrapped up basically what we've been discussing throughout the entire COFIT, whether it was embedded security, machine learning, or it was monitoring of network traffic. We are humans dealing with technology, and just the same way that the introduction of the steam engine had great socioeconomic impact because people had to suddenly deal with a new way of functioning, new way of manufacturing, new way of buying things. The same is happening with tech. And I wanted to say to all of you as students or the general public watching this, do remember that technology is a multidisciplinary thing. It doesn't matter where you come from. It does concern you, and it does concern your life and your future. And it's important to educate yourself in it and have an open mind. It's not the techies versus the business developers. Like, we're all in this together. And fundamentally, without sounding super cheesy, like out of an American film, the future is changing. COVID rapidly accelerated that social, political, economic change that is everywhere around us. And the only way that you can be prepared is if you are generalist and adaptable enough that you do have an open mind. But similarly, you actually get your hands dirty in practice and see how all these wonderful theories work in real life. With that, I would like to close off the machine learning and AI block, which also ends the 3 days of COFIT, the technology marathon or festival, if you like to call it that. It's been great. I absolutely love it. Not only would I like to thank Pavel Kordík, David Pešek, Ondra Brem, Zub, and also Eliška Novotná, who've done an amazing amount of work. I would also like, I don't know if she's watching, I think she's celebrating already, but Alča Brožová, who's a part of our team, it's her birthday today, so she is very integral to the FIT and COFIT vibe, so I hope that she has an amazing time. She got a personalized pint glass for her birthday, so I hope that she's putting that to good use. And apparently Pavel Kordík also has birthday today, and I did not know this. That is, well, 2 birthdays today. Well, Pavel Kordík, we are going to buy you a beer. You do amazing work, and you're the heart and soul of the Czech AI tech scene, a healthy punker and a great guy. So thank you for putting all of this together. Thank you everyone for attending. We will be doing a review of this. We'll do some kind of a beautiful video and hopefully do it bilingual as well, so we can get the great Czech talent out there into the world and show the world the great people that we have. Thank you again. We have today at 8 o'clock, if you don't have any plans for tonight, and even if you do, we've got a pub quiz. I'm running the pub quiz, so there's going to be mainly archaeology questions, but if you want that, come along. If you want to learn more about Julius Caesar and things like that. And then we'll have a discussion as well. Tomorrow there's a workshop and a bit of a hackathon happening. So make sure that you check out the website and sign up to that. And don't forget to network amongst yourselves, but also with the companies. You've got a unique opportunity, so it'd be stupid not to use it. I've been Sarah. It's been a great pleasure being here with you. Thank you so much. Na závěr ještě přepnu do češtiny, ať to máme zdravě, patriotické. Všem moc krát děkuju. Byli jste skvělí, užijte si večer. V 8 hodin se vidíme na PubQuizu, na Together platformě. Díky všem, ještě jednou veselý narozeniny Pavlovi Kordíkovi a Alče Brožový a všem mým kamarádům, se kterými jsme to dali dohromady. Je to pro nás srdcovka a máme radost, že se vám to líbí. Ještě jednou děkuju. Technologiím zdar, nebojte se jich a ať vám jde studium a zase se příště vidíme. Díky moc a ahoj.